Please welcome President and Chief Executive Officer for Cadence, Dr. Anirudh Devgan.
Hello, everyone. Welcome to CadenceLIVE. We have an exciting day for you. And we'll kick it off with a truly amazing guest, person who needs, virtually no introduction, known by first name throughout the world, the most premier business leader and technologist. Please welcome Jensen.
I love Cadence. What would I do without Cadence? I'd still be a busboy at Denny's, that's what's going to be.
Jensen, welcome.
Thank you.
And thank you for the collaboration between the two companies, and thank you for your friendship and partnership.
Yeah, so much is going on, and we're doing so much together. Yeah, so much is going on, we're doing so much together. We have some pretty exciting news today.
Absolutely. So before we get to the exciting news, one thing, of course, you are driving this amazing transformation. It's affecting all industries, affecting all kind of regions of the world. So what's your assessment of the state of AI? How is AI now? There's a lot of, 1 year seems like 10 years in this space.
Yeah.
So what's your take on current AI state?
Let me answer that through two lenses. The first lens is what's happening to the technology, and the second lens is what's happening to the industry. So the technology, as you know, the last time we spoke, we went from perception AI to generative AI, and we can understand all kinds of modalities now. We can translate from text to text and image to text, but even text to images. And so we now have generative AI. We're now well into generative AI, into the world of reasoning AI. And so now you could give it a prompt, you can give it a problem instead of a one-shot answer. The AI will reason about it step by step. Before it takes a one-shot guess, it might reason about it so that it can even answer questions that it's never seen before, just through rules and principles and maybe through reading, and right? And so we now have it would go off and read, get some information, read about it, go to the next step, think about it. And after it's done, it might even reflect about the quality of the answer. And if it's not good enough, it reasons about it some more.
It's good to see that. Sometimes tells you what it's doing, right?
Yeah, exactly. Yeah. It's not very confident about the answer. And then, of course, the next generation beyond that is physical AI. AI that understands the laws of physics, the common sense of the world, understands friction, inertia, cause and effect, object permanence, gravity, those kind of things. So reasoning AI gave us a whole new category of products called agentic systems, AI agents. And this is going to be very important in the work that we do together with JEDI. This is our vision that someday all of our chip designers would have a whole bunch of assistant chip designers. Just as every software engineer today has already coding AIs, every chip designer in the future should have assistant chip designers. And every system designer would have assistant system designers. And we're going to hire a whole bunch of them from Cadence, right? And so I hire one biological engineer, and then I rent 1,000 from Anirudh, and then every Biological engineer is a super biological engineer,
exactly.
Right?
They have a whole team. They have a whole team.
Right, exactly.
Yes.
And so now that's the agentic AI. The next generation of where physical AI comes into the world is robotics. And so we're seeing all that. So that's kind of the technology arc. The industrial arc is every bit as interesting. We talk about what AI can do, the technology aspect of it, what its applications are, how it's changing SaaS, how it's changing the way we do work, how it changes the type of products that we could build, right? So everything from the way companies are run, the way factories are run, the way products are built, and what they can do completely changed. That's the kind of the technology layer. The second layer is now recognizing that this form of technology requires manufacturing. You know, and the work that we're doing together recognizes that there's a whole new type of factory that's necessary, and we call it AI factories. You know, instead of calling it AI data centers, because data centers had a purpose and it holds files and supports all of our employees and runs our ERP system, you know, that's not going to change. Data centers are going to continue to run software that we wrote. And, but there's going to be a new type of data center, and I call it AI factory because it has one purpose and one purpose only. You have this big machinery inside. Instead of 300 years ago, the dynamo system that produces electricity, now we have these AI supercomputers, and they produce tokens. And every single day, they're producing millions and millions of tokens. And so you pay for electricity coming into the AI factory, and that's dollars per kilowatt hour. And what goes out is millions of tokens per dollar, right? And so between those two ratios, you know, that's your revenues, that's your profits. And that these AI factories are fairly gigantic. The next layer, technology, industrial, so this is a whole bunch of new industries, new companies. And the next layer above that is infrastructure. People are starting to realize that every country, every company will need this infrastructure because it affects everything we do. Just as profound as electricity was, we had the energy infrastructure, and then we had we are in the generation that invented this new infrastructure called information infrastructure, right? Nobody understood what we were talking about, turned into the internet, the information superhighway. Right. And so now we have a new superhighway, the intelligent superhighway.
Exactly.
And the world doesn't understand it yet. But clearly in 20 years' time, when you look back, we'd be sitting here, you know, for the first time talking about this new infrastructure called intelligence. And every country will have it, everybody will use it, every company will build on top of it, every industry will be affected by it. So that's kind of the two lens, I would say.
Absolutely. Thank you. You know, one thing I'm amazed by is, you know, of course, Hopper was a huge jump. I mean, NVIDIA has transformed continuously, right? And then Blackwell is even more amazing than Hopper, and we have all these exciting results in Blackwell. And then at GTC, you showed this really impressive roadmap going out several years. So I think what I'm curious about is how do you know, like it's very difficult to have this kind of such a big and important company, but at the same time innovating at a very fast pace. So how do you do that? What is the culture? How do you make sure that such a big organization, so critical, is also out innovating, out executing? It's truly remarkable to see. You're running a master class in how to run these lines. So what is there some thoughts on, you know, for the audience?
Well, there are two things that, and in fact, this is perfectly aligned with the vision that you described for Cadence when you and I first met. Got together when you became CEO. Yeah. If you look at the chip level, I would say that the chips are continuing to advance because we could obviously make them larger. We could stack it in a whole lot of different ways. But those are kind of incremental. You know, they're 50%, 63%, 24%, that kind of incremental type stuff. And it's important. We'll take all of it. And we also reformulate the way computation is done, maybe using things like tensor cores. So instead of processing in vectors, maybe you process it in blocks. Maybe we change the precision of the way we do mathematics because obviously neural networks is not precise, it's statistical, and so therefore maybe each one of the layers could be done in different levels of precision. Maybe sparsity could be taken advantage of, and so we'll do all that kind of stuff architecturally. But the big idea really is that we're no longer just a chip, we're a whole system. And in fact, we're not just a whole system, we're a whole data center. And if we could innovate the architecture at the whole data center level, and so Blackwell, of course, did all the things that I just mentioned, used all the latest technology and all of the tricks that I mentioned. But we also had NVLink 72 that scaled up the compute nodes And by doing that, we have to create new SerDes, we have to go to liquid cooling, the system has to be redesigned, so the way the system looks is completely different than the past. We refactor the way that systems are interconnected, and so it looks different. The cabling is different, the architecture is different, but you know, if that whole thing is a fabric for you, you know, for innovation, is a medium for innovation, then all of a sudden your creative ideas can come. And then beyond that, how we scaled it out was different. And so we could change the switches, we could change the networking protocols, and then on top of that, we rewrote the operating system of how software is deployed, and we call it Dynamo. And so basically at every single layer, we changed it. As a result, you got, you know, instead of 2x, you got 30, 40, 50x. It's kind of crazy.
Exactly.
Yeah.
You know, one thing we have talked for years, and Jensen has.
Oh, but I was going to say.
Yeah.
But that's the reason why Anirudh went from EDA to SDA.
Exactly.
There you go. Yeah.
Exactly.
System level design.
So we have discussed this for a while, you know, not just chip design, system design. Also, Jensen asked me even a few
He
years
always
ago.
asks me questions where he already knows the answer. You know what I'm saying?
No, it's because, you know,
Yes.
people want to hear from you, Jensen.
Okay,
They want
yeah,
to know.
yeah, whatever.
Yeah.
Yeah. He knows, look, that is the new vision of Cadence. To move the design automation, move the design medium from a chip to an entire system.
Yeah, exactly.
Yeah.
Now, one thing you also asked me and told me for years, if you remember, so, you know, first of all, as you know, we have a great partnership on Palladium, right? And Palladium is like a Boolean supercomputer, so it can design chips, especially like logic verification, emulation, which is critical for design. But Jensen always asked me, like, what about rest of the stuff, you know? There's a lot of numerical computation, there's a lot of other system, you know, other disciplines for engineers, right? So can we accelerate sciences in general, you know, design activities? And we also have wanted to do this for a very long time, actually. And actually, you were saying that you were, like, why has it not happened in EDA and SDA? And what I told Jensen at that time was that, you know, like, if you go back like 10, 15 years, we did a lot of what we would call parallel computing, but we did it on the CPU because we didn't have a good architecture. But now, especially with Hopper and then with Blackwell especially, not only, you know, everybody knows GPUs are fast, but I think what people don't realize is that GPUs have become a lot more general purpose at the same time.
Right.
You know, have become a lot more. And then you have now Grace and CPU to go with the, you know, closely, and the NVLink and all that. So finally, I think, you know, a couple of years ago, it was clear to us, and of course you've seen this for a while, that this can be a computing platform for much bigger things, more general purpose application, okay? And that is what we want to announce today, right? This is years in the making, and it's a combination of advancement in the, on the hardware and system side by NVIDIA, and then of course we have to rewrite our software to take advantage of that.
Yeah.
And you know, you always talked about this hardware and software together.
Yeah.
So let's roll the video, okay? Yeah.
Wow. I know, they're in shock. They're in complete shock.
So Jensen, you know,
That's beautiful.
we're
That's
trying,
beautiful.
trying to learn
Well-
from your beautiful videos.
Yeah. Well, hey, so this is what happened. You know, as you know, Palladium was going back to the origins of our company. We deeply believed in the concept of chip, system, and software co-design. And if you don't co-design, then you can't innovate in that loop at the same time, obviously. And ultimately, accelerated computing is not general purpose computing. Accelerated computing is about accelerating the software. And there are only certain algorithms that are conducive to being accelerated. And that's why co-design is so important. You have to change the algorithm, change the architecture, change the algorithm, change the architecture. And so So that Palladium was so deeply ingrained in our company. In a lot of ways, don't forget what Palladium is. Palladium is NVIDIA's digital twin. It is the digital twin of the most important thing we do. Long before we taped out Blackwell, I knew Blackwell was going to be perfect because it lived in it lived inside Palladium for a long time. Isn't that right? It was alive to me for a year. You know, I was only wondering when it was going to pop out.
Right.
You know, and so. Like, it's been alive in Palladium for like 9 months, you know? and you just
you can
wondered
run
if I bought twice as many Palladiums, can you do it in 4.5 months?
Yes, we'll
now
try.
now that I said that out loud, it kind of makes sense. and so the thing that's really incredible is beside our chip digital twin, we've never been able to digital twin almost anything else. And we want to digital twin everything we build. And that's the reason why Millennium M2000 is such a fantastic vision. Now we can accelerate the rest of EDA, we can accelerate SDA, and now we're gonna have digital twins of everything that we do. And I didn't tell Anirudh this, but today, I would like to place a purchase order right here on stage. Right here on stage. I haven't told anybody yet. Okay, so right here on stage, 10 Millennium M2000s. Maximum configuration.
Thank you, Jens.
Whoever the salesperson is calling on me, just, wow, home run.
Yeah.
He's there doing the math, and he's going, I like this. This is going to change. And so this is a big deal for us. We started building our data center to get ready for it. We're obviously working on accelerating the EDA software, the SDA software. With Millennium, we'll speed it up 50, 60, 100 times. And as a result of that,
some of these numbers, so that you can see, it's interesting. See, one box, of course, has a bunch of Blackwells and optimized software. Depending on the application, is equivalent to tens and thousands of CPUs. Sometimes 80,000, sometimes 100,000. Depends on the application, but that's huge. And you know,
listen, everybody, I just got to pat myself on the back.
Yeah, amazing.
Good job.
And the thing is that, you know, like we have done, because a lot of times the customers will run these applications on multiple CPUs like we have done. But there is a limit to how many, even if you have a lot of CPUs for one job, there is a limit of how much we can do. And I did this for, you know, from 2005 onwards, we ran on more and like, not just on a single chip, you know, like 8 or 32 CPUs. But there's a limit to few hundred. After a few hundred CPUs, the application will not scale. So typically, you know, a lot of the use cases are 300, 500 kind of CPUs for one.
It won't scale anymore because the overhead of communicating with each other, you know, this is the Amdahl's law problem.
And then, you know, with Blackwell, not only there is more compute in the chip, but the interconnection between the chips and all. So the thing is that, yes, it is equivalent to 10,000 or 50,000 CPUs, but you can never run a job. So it is actually more impressive than it looks, because you can never, even if you had 10,000 CPUs, it will not scale that well.
That's right.
This is for single applications. And if there are multiple, you know, batch runs, you can always tag them together. So, and then, you know, what is exciting is the breadth of the application. You know, silicon system and of course bio. Bio also requires a lot. So thank you, Jensen, for this collaboration.
Yeah,
thank you
I really appreciate it. So let me just say this, and you know, I'll just bring it back down to earth. For us, we're going to design the entire system completely inside a digital twin, and we'll simulate it as if we put it into, you know, a heat chamber, as if we literally turned it on and see exactly how it's going to perform thermally. We're going to put the entire data center, the entire AI factory, and we've put that together right between us. We've built an entire AI factory and simulated its thermal performance and found the heat, the hot spots, and how to ventilate, how to cool that entire AI factory completely inside a digital twin.
Exactly, with the Cadence Reality digital twin, with Omniverse.
Yeah, exactly.
See, that's the other cool thing that I think sometimes people don't appreciate the power of Omniverse. Of course, everybody knows this one. And Jensen and I talk about this 3-layer cake. Of course, he has cookies and I have cake, but he does a lot more. By the way, I've seen your videos. You like taking, in your kitchen, right? With COVID, you had like out of the oven, you take out like. Yeah, that's impressive.
That's how you cook. You use an oven.
Yeah. But
now I make them and I put them into ovens.
Exactly. Right.
Yeah, they came out of the oven. Now I got to put it back in.
So in that, in the digital twin with the Cadence reality, we talk about this 3-layer cake, talking about oven. So you talk about the accelerated compute at the bottom, and then the principal simulation in the middle, and then AI orchestration and agents at the top.
That's right.
So everybody knows that NVIDIA is of course doing a lot in AI, of course doing a lot in accelerated computing, and in principal simulation, of course we have a lot of history. But NVIDIA has done a great job with Omniverse. So not only built Cadence Reality, it's all plugged into Omniverse.
Yeah.
And then you can simulate the.
So now you have a virtual wind tunnel, virtual AI factory, virtual entire manufacturing plant. And everything is running with software in the loop. The simulations are either principally based, fully accelerated on Millennium. And so, or it's AI infused.
AI infused, yeah.
Right? AI
Phys ML and all,
That's
because just like in graphics, and you talked about at GTC, you don't have to render each pixel physically. You can do with AI. Same thing in simulation. If there are multiple time points or multiple variation, not only can the principal simulator be accelerated by accelerated computing, it can be further accelerated by AI.
That's right.
By not doing each point and do this model.
You ground every, you might ground every few frames or every few pixels, and then you predict everything else.
Now on the AI factories, okay, that's a big thing, and thanks for this like Cadence Reality collaboration. But what do you see with this? This thermal is a big problem, right? And so
I'm going to be asking for a delivery schedule here pretty soon.
Okay.
You could tell he's trying to change the subject.
No,
I placed the PO.
I'll drive the truck myself.
Okay.
Yeah, I'll drive the truck myself.
Right. Okay.
I'm coming.
So it's 1.5 tons each.
Yes, I'm coming.
Okay.
Yeah, we'll get it. We'll get a few trucks, Jensen.
Okay.
Yeah.
I just bought 15 tons of computing.
Thank you. Yeah. Isn't that exciting? No, but that's a very good point, that NVIDIA, and of course we collaborate on the EDA and the SDA, also uses the latest.
We're working on Jedi,
Yes.
Agentic AI, right? We're working on Millennium, accelerated computing and AI emulation for digital twins, for simulation of everything, emulation of everything, digital twins of everything. And then we're also working on Orion, our digital biology platform.
Yeah, exactly.
I'm on top of my stuff.
Yeah, you are. Yeah. No, I'm coming with the truck. I'll bring few trucks and we'll make sure it works. It's like I want to have a same photo like you had with when you delivered a box to OpenAI. That's the thing. I'll deliver a Millennium box.
Okay,
Yeah.
I'll be ready.
Yeah.
I'll be ready.
So Jensen, one thing that on the digital factory side or AI factory side is this whole power consumption, right? It's huge. It's a huge problem, right?
Yeah.
And then that's why we have this,
We're building AI factories that are 1 gigawatt large. 1 gigawatt AI factory, the capital necessary is about $60 billion. $60 billion. Just so you know what $60 billion is. $60 billion is like Boeing. Not the plane, the whole company. The revenues of the whole company is one AI factory for a year. Okay, and so that kind of puts it in perspective. And we have tens of gigawatts of build out in the coming years.
And then, of course, NVIDIA also has DGX Cloud. Okay, that's exciting. And this whole building of factories and all your partners throughout the world, what do you see in terms of, like power consumption, of course, is a big thing now. But one thing people don't realize, even for Millennium, if you do it for the same, ISO performance, it's 20 times lower power.
That's right, exactly. Right. That's the whole point.
Because a lot of time people talk about how much power these things are taking.
Yeah.
But for the same, to do that computation is still much more power efficient.
That's right. It's never ever about power. It's about power efficiency. Always about power efficiency. So let's put that into money. And so let's say you built a data center, it's an AI factory. Everybody's AI factory, some people have more capital than others, but the power that's available to that AI factory is the power that's available to that AI factory. That's it. That is the only laws of physics. And so whatever you provision, that's all you're going to have. Well, if you're limited by power and your goal is to maximize the million tokens per dollar, okay, then you're trying to maximize the million tokens per watt. And that, if you maximize million tokens per watt, per watt, then your revenues will be the highest. And so if the architecture has 20 times, using your example, 20 times the performance throughput per unit energy, then the revenues of that data center is 20 times higher. That's the amazing thing. That's why it's an AI factory.
Exactly.
It's ultimately about revenues generated, and this is the future. We have a new, the last factory was, electric power plants, and the more energy efficient they are, the more kilowatt hours they generate, and therefore the more dollars they generate. Here is the more tokens you generate from the data center, and more tokens you generate, the more dollars you generate. It's a very, very big deal. The difference in architecture perf per watt being 2x versus 3x versus 4x, just translate that to revenues. Would you like to be a $10 billion company this year, or would you like to be a $20 billion company this year? That's it.
One thing on power consumption, I saw all these reports that, people are putting generators right next to the, and some are on the grid, some are like local power generated. So
power generation is going to be a big deal. The reason for that is because the power grids aren't going to be enough to sustain the growth of this industry. And this industry likes to be built, we like to build this industry on shore. And if you want to do that, then we're going to see a lot of, we're going to see, of course, a lot of diesel power generators, and you're going to see some SMRs and, all kinds of stuff.
And then the other thing you have talked about is this whole, there's these big cloud providers which have, of course, footprint all over the world. And then there is these sovereign AI, people, all these countries are building their own models, and they need to, right? So, and then there are these enterprise AI. So how do you see these different parts of the market, right?
We're in the first stage of AI. If you look at all of our economic success, everything that's been done, everything that's been talked about, it's basically cloud AI.
Yeah.
It's basically AI for the AI natives. These are startups, brand new companies. OpenAI is a new company, right? Perplexity is a new company, really fantastic. All these are new companies. Runway ML is fantastic. Black Forest is fantastic. There's a lot of really cool companies, but they're AI natives. But you and I know that AI is going to infuse into every single aspect of everything we do. Every company will be run better because of AI. We're going to build better products because of AI. And so the next phase, the next chapter is enterprise AI. The architecture of enterprise AI is very different. Like, for example, a lot of companies still run off of their mainframes. IBM mainframes and Fujitsu mainframes. So the question is, how do we infuse AI into those systems? You can't just cleave it off and say we are going to brand new enterprise IT. You're going to have to add to it. And so you and I both know that no IT systems ever passed away. And so standards just keep getting added on top of each other. And so we're going to have to augment AI into the world's enterprise AI system, and that's one of the initiatives of our company is enterprise AI. Whole new systems, whole new networking, whole new storage stack. Everything is all brand new, yet integrated into existing software infrastructure. It could be VMware, it could be Red Hat, it could be even classical Java, and one of the things that's really going to be really cool is AI understanding COBOL, right? And so that's enterprise AI. The next click after that, simultaneously with enterprise AI is exactly what you say, sovereign AI. Every country is going to build their own infrastructure. They have, your AI, your intelligence embeds your history, knowledge, culture, values. That's in collection is intelligence. It's not just knowledge, right? It's not just things you read in a document. And so So intelligence has to be something that is codified and built in each one of the countries, in each one of the regions. And so you're going to see this being built out everywhere. We're building out United States, that's first, but countries all over the world. Japan is getting built out, UK is getting built out. All the countries are getting built. India is building out, and so there's a whole bunch of initiatives going on. And so that's simultaneously going on. And then the next click after that, the big idea, this is the really big stuff, is industrial AI. That's the physical AI, the robotics. Omniverse is designed for that.
Absolutely.
All the things that we were just talking about. The number of plants and factories being built around the world is incredible. For all of the geopolitical reasons and otherwise reasons, people realize that reindustrializing their country is really important for economic security, national security, not to mention a stable society, because you have a distribution of different types of workers and different type of labor that needs to be available in different societies to balance it out, to properly shape that society. And so reindustrialization is going to cause plants and factories to get built all over the place. We're building a whole bunch here. And we want to build it first in a digital twin, simulate it as a digital twin, and then build it. Just like we build, right?
Exactly.
Just the way I use Palladium, build Blackwell.
That's why.
Is that right?
Millennium can do that.
Yeah.
But the physical AI itself, there's a report, there's so many
Palladium was a home run. Millennium is going to be a giant home run.
Exactly.
Giant home run.
You heard it first
New,
here.
Yeah. Giant home run. New product category for this entire industry. Isn't that right?
I love your code. I don't know if you see.
New product category.
New product category, right? With this physical AI, there's so many reports. Even 2 days ago, there was like Morgan Stanley report.
Just so you guys know, we didn't rehearse. I don't even know when I'm supposed to leave.
See, the thing with Jensen is that he's always ready. You don't need to rehearse. When do you need to rehearse? You're always, always
I'm
know
your
everything.
wingman. He's Batman. I'm Robin. I'm just.
He's 100% charged, 24 hours, right? Yeah. Right? So, I saw a report 2 days ago. There's so many reports that robots will be $5 trillion market.
Yeah.
That's huge.
Yeah. Well, on first principles, just go back. It turns out the world has a severe labor shortage. While we're sitting here talking about AI, changing jobs, taking jobs, first of all, AI is not going to take your job. Somebody who uses AI is going to take your job. And so you have to engage AI. But obviously, AI is going to change every job. And that's for certain. It's changed my job. It's changed every job. And a software programmer at NVIDIA, job completely changed. But the world has a severe shortage of labor. The people that society is changing, its preference for the type of work that they do, population decline all over the world, right? We know this. And so we know we need AI and robotics to come, and because otherwise, the world's GDP is not sustainable.
Right.
And we want the GDP to grow, and we want inflation to come down. And so the only answer really is we need to get to robotics as fast as possible.
And that is a completely different stack, right?
Yeah.
The hardware, the chips are different. You're designing special chips for robotics.
Yeah.
They have to be much more power efficient than the cloud. The simulation, digital twin is different. Has to be like.
We built the world's first robotics processor. It was called Xavier.
Exactly.
And when I first built it and I showed it to everybody says, I don't know what that is, don't want it. And then I built, and because I was so deeply hurt by the reaction from everybody, I built the second one. And so obviously I didn't build that one well enough, or I didn't tell you hard enough. And so I built the second one. It's called Orin. Home run, bam, home run.
Exactly.
Self-driving cars, robotics.
Yeah, and then
autonomous systems.
Autonomous
edge AI.
system has a lot of similar.
Yeah.
So the cars.
Multi-billion-dollar business for us now.
Exactly.
Yeah, crazy. And so we got another one coming. It's called Thor. And so, yeah.
So the chip is different, of course, and the system is, the hardware system is different. This digital twin has to be different, with more numericals or something like
and
Millennium.
So now,
Millennium.
Omniverse is the software version of digital twin. I'm going to plug Millennium into it.
Exactly. That's Omniverse.
That's
exactly.
right. That's the digital twin.
And then the AI model is different. You want to talk about, you have a new AI model, like physical, you talked about it at GTC, right? I love that. You have this new, it's not an LLM model, it's like a word model, right? So all these three things.
So this is an incredible thing.
Yeah.
If you could have models that reason, text models that reason, you could have physical AI models that reason. So you're driving down the road, and the AI model that's in the car, of course, is a physical AI model. It understands the physical world. Okay? It understands you can't go through this, you can't go through that, and understands how to reason about traffic and roads and road signs and reasons about all that. And so you come up to a stop, you could actually ask your car, what are you going to do next? And the car will explain to you, I see this, I see that, and therefore I've decided I'm going to pause for a little longer before I take a right turn. And and if it does something wrong, you could actually reprimand it. What did you do wrong? And the car will say, well, I think I might have missed that, I'll never do that again. Good, Reasoning AI,
Right.
so credible.
So the models are different, right?
Yeah,
For the
yeah.
car, for the robots, for the
It
drones.
understands,
Yeah.
it understands that if it has to go from here to there, it can't go through this table, it's got to go around.
Right.
Yeah, kids know that, dogs know that, yeah. But AI doesn't know that. So we got to teach an AI to know that.
Absolutely.
Yeah.
Absolutely.
Pretty cool.
Yeah, that's why I really like that, the new kind of word, you call it a word model, right? Rather than
Yeah,
LLM model.
it's a world model, right.
So all the three layers of the stack, they all get transformed. But there's automotive, in physical AI, there's automotive autonomous systems. There is like humanoid robots.
Yeah.
There's industrial robots.
Tens of
there
millions
is
of those
drones.
needs to get built.
So is like, I know you're working in all of these areas, but is one like more, in the physical AI, one will happen faster than others, or how do you see this different?
The one
parts
that's going to happen fastest, largest, is self-driving cars. That's already a $5 billion business for us. Yeah.
Actually, I went to China a few months ago, and there are all these AV companies,
Yeah.
and they're all using NVIDIA chips and software. It's remarkable. This BYD, all these, you talked about that, it's quite remarkable how well. Because people don't realize that. They realize the cloud part, but not the automotive part of NVIDIA. Right?
We're a three-computer company.
Right.
We're the one that trains the AI models and the digital twin, Millennium, and then the edge computers,
Yes.
the three-computer company. Yeah.
So you think the cars will happen first?
First, because it's the
Yeah.
easiest. In a lot of ways, it's the easiest. If our parents could drive, how hard could it be? And so and it was. Remember, we shaped the world for our limitation of our systems. But for human or robots, you can also shape the world. We could put them into specific domains. That's why I'm quite enthusiastic about humanoid robots. You don't have to build a human or robot that could operate in any part of the world.
Yeah.
You could give it a particular domain. You could adapt them. They could do quite well. But these two will likely be simultaneously large and quite successful. And the reason for that is because technology needs a technology flywheel. And if the volume is not there, then the innovation cycle can't be there. And so what are the two autonomous systems that are highly generalizable? Cars and humanoid robots. Both high volume,
Yes.
right? And
It could be like billions of humanoids
that's
over
right.
time, right?
That's right. Yeah. And then
And there are
now the
already
human
100
robot
million
flywheel will
cars.
be quite
Yes,
high.
yes.
And then its innovation cycle will be very fast, and therefore it'll get good fast. But if you change the shape of it, I think a quadruped could be quite good too, because we've created a world where dogs could be quite successful, and so I think a quadruped could be good. But otherwise,
Especially off track, right?
yeah,
Off-road,
right, exactly.
in jungles or
Exactly, yeah. And there's even ones the one that I'm super excited about is the one from Kawasaki. Basically a robotic horse, and so you could take it through all the different terrains, and you're riding it. That makes a lot of sense to me.
Yeah.
Makes a lot of sense. Super exciting. That's a horse I might enjoy
That's the
riding.
photo I want to see. You on a robotic horse.
A
That would be
horse,
great.
that's it.
And then, Jensen, we have only a few minutes left. I know you are a very busy schedule. I mean, the other thing we
I have
didn't
nothing
touch.
else to do today. This was it.
Yeah, thank you. One thing I do want to touch on is we talked about, of course, the Agentic AI. We talked about, physical AI and all digital twin to accelerate. But one other thing I know both of us are passionate, or you talked about it for a while, is bio, you know. We always believe computer science and math has to be applied to bio and life sciences, right?
Yeah.
That's why, you know, Cadence, we started this effort a few years ago.
Yeah.
And I know you have a big effort.
Yeah.
So how do you see that part in this, you know, life sciences, bio, you know, with AI and
In
etc.?
a lot of ways, the journey is very similar to our journey with EDA. You know, the idea that there would be an EDA company for biology makes perfect sense. Today, it's called life science, and we call it drug discovery. Drug discovery is funny. It's a funny term to me, and it makes a lot of sense. It's kind of like truffle discovery. You know, you go out, and then one day you come back, you go, hey, look, honey, look what I brought home. And then someday, most of the days you come home, you don't have anything, okay? But engineering is not like that. You know, NVIDIA engineers don't come home and, hey, you know, Jensen, listen, this year was pretty much a bust. Didn't find anything. You know, you can't have chip discovery. And we have, right, we have chip design. And so in the future, of course, it's gonna be drug design.
Yes.
And in order for you to drug design, to design exactly the right drug, you have to, your in situ, your environment has to be well represented, well understood. And that environment is cells and, right? And the human body and, you know, and so we have to be able to represent that environment, that systems environment really well. We have to understand how to represent it. The way we represent transistors and gates and functional units and, right, C models and ultimately system models, that representation, that stack of representation has to be created for digital biology. And then once we do that, then there's manipulation technology, you know, and then probably simulation based. Some of it is AI based, and some of it could even be, you know, hybrid, you know, quantum classical. You know, we might be able to use quantum QPUs connected to your Millennium processors, and so I could imagine a quantum Millennium someday, you know, and so our GPUs sitting next to QPUs and use the QPUs for first principle simulations of you know of the biology, and we use that to train our AI models on Millennium, and you know, so I could see all that, and so that's kind of the future. But the exciting thing is, because of your vision, you've really given Cadence now several new growth vectors. One, you're in system design. Two, you have digital. Just as you have Palladium for chip design, you now have Millennium for SDA. You know, and so you have this brand new growth driver, and hopefully together, we have the chip design or engineer agentic system that you'll provide for us.
In the core business, you know, the EDA, the hardware. No, Jensen, it's a fabulous collaboration. I want to thank you for working with Cadence so closely, for being such a teaching customer and driver in the industry, and for the personal friendship and partnership.
Yeah, thank you for the
honor
friendship, and thank you all of the Cadence engineers in the audience. Thank you very much.
Yes, thank you. Right.
I love Cadence. And if not for Cadence, just so you know, if not for Cadence, I'm still a busboy. Just so you know.